right. All right, so as Beth said, my name is Nolan Doyle. We're going to be looking at Desmos calculators for middle school in North Carolina today. So thank you all for joining. This bit.ly at the bottom here, and it'll be on the slides throughout if you don't get it right away. But as I navigate through, that will be there. That has a detailed look at our agenda for today, as well as a bunch of links that I'll reference throughout on that first page. And If you're using the graphing calculator, that account allows you to save different graphs, and also allows you, if you were going to go to Desmos Classroom and run activities, you could use that account to run and create and save your own activities there. So as we get started with the basics, the first thing I'm going to kind of expose you to is just where to access the different calculators. So if you maybe look back at these slides, you can see as I'm going through, if I go a little too fast, you can always reference these pictures that will show you. But more importantly, in the agenda, I've got direct links to everything I'm going to go to. So you can get these links here. You can bookmark this agenda as well as bookmark each of these individual links as we go through them, the ones that we want to use. So if I go to desmos.com, my home screen under math tools, that's where I can get my graphing calculator, my scientific calculator, four function calculator, those general versions of them. But we want the specific North Carolina version. So I've linked both general scientific, general graphing calculator with different help links here for those. But then as we get to the highlighted ones, these are the actual specific versions for North Carolina. So we'll look at those and talk about what those differences are. So you can get there from those links, but you can also go under resources here from desmos.com and under assessments. Okay, so resources and assessments will take you to that map that I had in my slideshow. And we can click on North Carolina. And the first thing I'm going to do is I'm going to open up that PDF in another tab. And when I look at that, we can see the differences between the testing calculator and the standard calculator. So I'm going to pull up then from here the scientific calculator, that is the testing version that you all have in North Carolina. I'm also going to pull up the full version. Okay, so when we look at the differences, there's only two differences. One thing I'll point out first is the keypad. So in the testing calculator, which I know I'm in the testing calculator because of this green band at the top that says North Carolina, grades 6 through 8. There are three kind of menus right here. There's not a lot of navigating. We don't want students spending a lot of time navigating, different menus, but there are three different ones, where one of which is the alphabetical keypad. And so in the testing version, it is alphabetical versus the standard one. If you go to the alphabet, it's the QWERTY keyboard. So hopefully that's a little bit easier for students that might be able to find those letters a little more quickly if they need to through the alphabet instead of the keyboard. The other difference is we can't define functions. So what that means is in the standard calculator, I would be able to type something like f of x equals x plus 5. I could define that function, and then I could go to another line and I could say f of 4, and it would evaluate there. If I try that in the testing calculator, if I type in f of x, I'm already getting an error message here. Too many variables. I try to type in here. This feature is not available in the current calculator. Okay, so those are the only two differences, but you want to make sure your students and you are using throughout the year, for the most part, this testing version here. One thing I do really like, we'll see this error message come up a lot, is that if you hover over it, that's how I'm getting the message. The messages are really helpful, much more helpful than a lot of times with a handheld. If something's not working, it's not really clear. So it's important to get your students in the habit of hovering over there. If something's wrong, like hover over there and see if they can't figure out from that message what's going on, because we all know once it's test day, we aren't able to help them with the calculator, but hopefully those error messages will still be helpful to them. All right, so I'm going to just kind of talk a little bit about some of the basics. And again, I'm going to hit these throughout a couple times. And if you don't catch everything, if I'm going a little too fast, you can always come back and play at your own pace. Again, I've got some resources in the agenda to come back to. This support for scientific calculator will take you to the help page. That's a great with videos and different kind of walkthroughs as well. So with the scientific calculator, as I mentioned, there are kind of three menus. The main one here has your numbers and operations, and the most common ones that your students are probably going to need. We do have that alphabetical keypad if we need to, and then some extra functions here under the function menu. And we'll reference a couple of these later on. Some of them are actually repeated from the main one, so you see them twice here. So if we want to do some calculations, I'm just going to start clicking And one thing you might notice is I don't have to hit enter or return or there's an answer button. Just as I put calculations in, my answers are going to pop up, which I like. If I put in another operation that's incomplete, right, I'm going to get that error message. It's going to tell me pretty specific that I need to put something on both sides. So I can continue. If I do hit that return key down here, that number, that result or answer is over here still, that result, and I'm now in another line. You might take note of when we hit the division key, that division symbol is not going to pop up. That is a difference from the for function as they transition to the scientific. So that division is going to be in that fraction form. If I want to get out of that, I can either click to the right or I can arrow to the right so that I could keep going with maybe another fraction, as well as the fraction button here I could use. So I can click in the different spots, and I can also use the arrows to do that. So as I have more lines, I can always scroll back to a previous line. Not only can I see it, but I can go back and I can adjust it. So I could go back and I don't have to pull this down or anything. I could just keep adding in different operations and get a new answer up here. So I do like that we're able to go back to previous lines and edit them. That can be super helpful for students, maybe as they're working and you want to come back and see, well, what did you actually calculate for that one, right? They don't necessarily need to clear that out. The other feature that I really like is the answer button. So if I hit the answer key here, it will give me the answer from the previous line, and then I could continue doing operations with it. I also like that I could go back to this line above. If I hit and I adjust it and I get a new answer, it's going to update my answer down here. And it shows me what that value is. It doesn't just say ANS, right? It shows me what that value is that it's actually using for the answer. I could keep going, use it again, and now it's just going to use the 27, the previous line there. So it's just going to use the answer from the previous line as I go through. These arrows right here are my undo, so I can undo one step at a time, or I can redo and go back. Maybe I hit undo too many times. I can also delete one character at a time with this X. If I want to clear an entire line, so let me go up here. If I want to clear the entire line, I can hit this clear button. And after I clear that entire line, if you look what happens, I'm going to click where it says clear, and now it says clear all. So I have the option to clear out the entire calculator and start fresh. All right, so those are the main features. I guess one more thing is this arrow right here. So this is what I was talking about when we have our fraction. So maybe I fill in 5. If I want to move out of that fraction, I can hit to the right here, or I can move to the left here. And I can always click on that fraction too with my mouse. I'm going to pause and just check in with Beth to see if there's any questions just on some of those basics and where to access these different versions.
Hey, all right. So we do have one question, more for me than for you.
Okay.
The question is that when our students use the Desmos calculator on the NC check-ins or the EOGs, the calculator pops up in the middle of the screen and kids can't move it. And this person specifies they use an iPad. So first of all, it's important for us to know which device you're talking about. So thank you for including the fact that it was an iPad. We have this on our enhancement list that we review once a year to look at changes moving forward. The iPad is probably the least, it's harder we have a, it's called kiosk mode, and that's how it kind of locks it down so the kids can't get out. And so the changes for the iPad tend to be a little bit harder to come by. The iPad also is, we have the fewest number of kids who test on the iPad. So I will forward this and let folks know that you would love to have it move. I know we've looked at this in the past and it was a security issue, but I will absolutely forward that on. We appreciate your feedback, and I will make sure that that is on this year's list. Oh, and then we have a question for you, Nolan. Can you show about changing units from degrees to radians?
Oh yeah, great question. So we have this toggle right here that does change from radians to degrees. So if I go to do one of my sine functions, sine of 30, right? So right now it is in degrees. If I wanted it to be in radians, I could toggle here and now it's in radians. So I want to change that to work into degrees and radians. So yeah, so it should, when you open this or when your students are using it, it will default to degrees if you want to use radians. So whatever is showing there is what it's using. Great question. And then I'll also point out, I did in the agenda put in a link here to go to the North Carolina testing applications. So we can go to the released items and look at the actual testing version to play around with so your students can access it as well. So not reading, but if I just pull that up and hit login, and that was a great question about the iPad. Glad you brought up that issue. So as we get to, I'm gonna have to click to get to the calculator section. We can pull up that calculator and see what it looks like. And so on here, I am able to move it around and resize it a bit, I believe. Yeah, so sounds like that option's not available through the iPad though. So, but that's what they'll see within the testing application. All right, so we looked at how to access, some of the differences, and also the released items, how you can use the calculator within. So I'm going to just to show some of those features a little bit more before we get to the instructional piece. I picked some questions in the middle school released items just to see some of the features in action. So this first one is scientific notation. And I just like the way things are formatted and how clean it looks for students. So they're not necessarily having to do a lot of work to kind of match up what they're seeing. So if I go to my testing version, I can put in, you know, basically exactly what I'm seeing. So I'm going to multiply by 9.46. And I didn't click, if you notice, I didn't click the multiplication. I can use my keyboard, that Shift 6. No, sorry, Shift 8 is the multiplication shortcut. And that brings up that time symbol. And then if I want to do an exponent, I could use directly from here. I could square it, or I could use any exponent I want here, that A to the B button. And then I can also do Shift 6 to get that exponent here. And again, that formatting of the answer is pretty clean and matches what students are going to see in their version. So sometimes with handhelds, what you're seeing on the screen is a little bit harder to interpret and translate to the clean version of the format they're seeing on the test. Here's a problem where they're going to have to make use of fractions. So we want students to practice entering those fractions in. There's several different ways that you can work through that. I'm going to go ahead and clear all here. Just have that one line. And so for this one, we need to multiply 2.5. So I'm going to put that whole number. And then I don't want to necessarily do like 1 and then try to do the fraction that way, right? So that's it's taking the whole 21. So one thing I can do is I can just hit space, or I can arrow, or hit the space bar, and then I could do 1 divided by 2. The other thing I do is just hit 2 and then the fraction button over here. So that's probably going to be the easiest thing to do is put your whole number, and now we want a fraction. So use that fraction button and put in our 1/2. And I'm just arrowing down to the denominator, and I'm arrowing to the right to now multiply. The other dimension was also 2.5, so whole number, fraction. I could also click to different spots right here. So whether I want to arrow or click, and click out, multiply. The last dimension was 3 1/4. So you'll notice we have the decimal answer here. If we toggle right here, this button pops up as an option to convert it to a fraction. It will convert it to an improper fraction. So if we look back at our choices, we might actually, the way the choices are, just keep it as the decimal and notice it's the 20, right? And then find the whole number of 20 there. We could also put in our answer choices and match. So I could leave this as the improper fraction, and I could put in 20 5/6. And notice nothing pops up here except that toggle button did. So it's not going to give me, I didn't do any operations, but it will, when I convert to fraction, put it into the improper fraction form. So from mixed number to improper fraction, I forgot to put the 16 on the bottom. And now we can see that it matches. Another fraction one, so we're dividing. So again, getting students to see that division, there's no division symbol in that line, making sure they're familiar with that. So in this one, if I'm going to put in the 85 and 1/4, and then when I hit division here, it's going to pop that into the numerator and pop me down to the denominator. So I can put in the 15.5 there. And again, it's in the decimal. I can go back and forth between decimal and improper fraction. I believe this one asked for nearest tenth, so that decimal form is actually going to be helpful to them. One more fraction one I put in here just to see the formatting, see what it's going to look like from the student perspective as you're working the problem. I'm not going to walk through that one, but that gives you an idea of getting used to the formatting, getting used to the division and the fractions and what that's going to look like with mixed numbers, as well as toggling back and forth between the convert to fraction, convert to decimal buttons. There is a mean function. So if we wanted to find the mean here, and we actually need to figure out what the score on the fifth test need to be. So the mean is exactly 80. So we can go a couple ways here. I'm going to go ahead and clear everything out. We can go to functions, and mean is one of our options. And so when I click just the word mean and parentheses, and we're ready to pop in our different values. So I'm going to go back to the main menu from function. It's really the most navigating they're going to have to do to menus, which is great. We can focus on just the actual math part. So 62, we're going to need commas in between each one. 75, comma, 76, and 90. And then we need to figure out what the last number needs to be to have a mean of exactly 80. So I like that we can easily put those in answer choices. So we can put in 80, it pops out the mean. That doesn't work. All right, I'm going to try 100. That doesn't work. Try the next option, 93. Hopefully this last one is what we want, and it is. Okay, so we can quickly use that mean function, and we can adjust that line. We don't have to make a new line each time and hit enter. We don't have to retype everything in. We can just pop in the different answer choices. The percent key, I noticed a lot of percent questions, it seemed like, in the released ones, but we definitely want to be familiar with that because that's probably a little bit different than what students are used to seeing or what you're used to seeing on a handheld scientific calculator. So we need to find 15% of 400 here. And so when we do that in the calculator, let's go to the next line. I'm going to hit 15. When I hit the percent key, notice it's what pops up is percent of. So we want 15% of 400. And there's where we get our 60. In this one, we need to find 25% of some number, right? Will give us 75, right? 75 sixth graders. So when we go here, again, we can make use of that idea of just putting in the different answer choices. So when I hit that percent, 25% of, right, of 100, that's one choice, of 200, 300 is what we want. So we can work through that to find that percent, 25% of what number is 75. The next one I pulled was to show a couple of things. One, there's a pi button that we can use. We can use that exact value of pi. So the more exact we can be, the better, right? And also, the other thing in here is we can use the answer button. So here's an example of how we might use the answer button. So we need to find the difference between two different pizzas. So we can put in our pi. So here's our pi button times 8. We don't even need our parentheses. We can just type it like this and it's going to multiply them together. So whether we put that multiplication in there or not, whether we put parentheses in there, it's going to accept all of those. And I really like that. Like, we want the calculator to work for students, right? We want as few error message as possible. So if we put that in there just like that, that works. And we want to square that 8. We want to do the area with 10. And then if we want to find the difference, right, I can always go to the next line and like type these in, but it could be just quicker. I could just go here and I can say, well, I need to subtract the one I found up here. So I can hit minus and then hit that answer button. Again, I really like the visual of seeing what number, okay, that matches there. That's what I wanted to subtract to get our value there, 113, and then go back and see which is closest to that decimal there. So the pi button is there for your use. One kind of little Easter egg hidden thing here is I can also just type in PI and that pi symbol comes up. So there's those keyboard shortcuts that can kind of help you out and work a little bit faster sometimes. All right, I wanted to kind of also show a few through the graphing calculator. So this one is an 8th grade one where they do have the graphing calculator, but also just show some features, even if you're a 6th or 7th grade teacher. The graphing calculator is something you can use for instruction, which I'll show you in a little bit. But it's not a bad idea to use it. You don't have to be like, oh, I can't use that because my students won't have it on the test. They can still be great tools to visualize some of these concepts and work through them. So here, we want to know the rate of change of a linear function. I find myself, I teach algebra and geometry, that the visual representation, the graphical representation can be so much easier and accessible to students. So especially when first learning, I might start with that representation. And then when they're on a standardized test, if that representation is easy to use, go for it, right? If it's quicker to use, it's cleaner to use, we want them to be comfortable going back and forth between different representations. We might not necessarily want them doing numerically the slope formula here, right? There's a lot of places to make mistakes. We still want them to know it, but in the high pressure, high stakes test, we want to make sure that they have a tool and a way to find that slope that's reliable. So if we go to the graphing calculator, which did not pull up yet, so let's go and let's make sure we're using, just click it there, the North Carolina one. We can plot those 2 points 3 different ways. So just to get a little bit familiar with the graphing calculator, we've basically just added the graph here. You can't see the on-screen keypad, but we can pull it up here. It looks very similar to the scientific. So we can do up here in our expression list, we can do calculations, but now we can also plot points and graph equations and inequalities as well through that expression list that will show up on our graph paper over here. The only menu navigating through the keypad here, that instead of those 3 tabs in the scientific, we just click functions and we can scroll and find any function that's available to us here. So again, that's the main menu navigating that students are going to have to do, which is not too much. So if I'm going to plot points, I'm just clicking on the expression list and I'm just typing in the actual coordinates. I want to plot the point 29 and it will plot. Now I have to find it over here. So one thing I like to do is I can either just zoom out real quick, right? I can zoom in, right? If I click too far, if I get lost, this home button just defaults to that original window I was in. I can also click and drag, almost like I'm just sliding a piece of paper. So I might zoom out and then slide this down here. Oh, my point got turned off. So I'm going to type that in again. Sure, what's going on there? Let me reload that. All right, so get our point back on there. I'm going to click and drag, and there it is. So I can slide it like a piece of paper. If I want to plot a second point, I can do a comma and then plot it, and you'll notice it will be the same color. Again, I can easily navigate this window to see those points. And now we could count that rate of change, that slope, which might be easier than going through and subtracting and maybe making mistakes with our signs. Okay, or if you're teaching it and you want them to be able to do it by hand, we can always use this. The student can use this to check their answer, right? So they can rely on it themselves in this tool instead of maybe you as the teacher or the answer key, right? So they can use multiple representations and make those connections between them. I could also just go to another line. If I plot -1, 3 on another line, you'll notice it's a new color. And so I can always click and hold here, and there's some options. I'm going to spend a lot of time on this for our sake today, but different options to, if you wanted to match those up, we could. The last thing that we can do to plot the points, we can put them in the same line. Sometimes students will forget that comma between the points, so sometimes it's better if they're putting them on different lines, right? They'll get that error message though, and the calculator thinks we're trying to multiply a point by a point here because there's no comma in between. But we can also add a table. So on this plus sign here, the expression is what it's defaulting to, that we were able to plot those points and we could graph equations, but we could add a table and it pops up with X1 and Y1. So we could put 2, 9 here. I can click, or I can arrow, or I can hit return to get to a new row. So if I just click down here, I want to add another point, -1, 3. Now those points that are black from the table here, I can turn those off completely so they're gone, show up. Okay, so we can plot points the same line on 2 separate lines or within a table as well. And what I really like is we don't have to go to a different screen. Everything's on the same screen. I don't have to go to a screen that's just the table. I don't have to go to a screen to enter in the points. It's all right here. It's all populating in real time, updating in real time as I enter that in here. So that might be a good way to visualize these 2 points and then count our slope, our rate of change. Here's another one. I won't go through, but it's basically plotting points again. So you could plot the original point, which we're focusing on, which is Y. And then we want to know which of these options is rotation of that point, 180 degrees. So we can focus on the concept of rotation, not necessarily if they're doing this by hand, or they're trying to memorize a rule of what happens to the coordinates, but they can see it visually. And I think being able to lean on that visual representation can be really, really helpful for students. Okay, what does it mean to be rotated? That concept around the origin. Have we provided some visuals in class that support seeing which one makes the most sense here? Instead of maybe just memorizing a rule of what happens to the coordinates, they can still memorize that rule, but it can be supported with that visual representation. Here's another one where we could use points to get a visual of, we need the length of RQ. So we could pop that into what I think is a very confusing distance formula, right? Or if we can plot these, right, we could set up a right triangle, right? The students could count one of the legs of that right triangle, count one of the other legs, and then maybe use Pythagorean theorem. So we could lean on that visual representation and creating a right triangle to figure out that distance. I'm gonna jump to, there's a couple other in here. I put this one, actually I'll do this real quick, is where if we know the relationship here is that they're equal, so 2x plus 15 is going to be equal to 6x minus 45, we could, in the graphing calculator, well, 2x plus 15 in one line, and so it's graphing it as 2 variables, the same thing as if it was y equals. We could put it in the other one, and even if it doesn't have y equals, it will still graph it for us. And we could navigate to find where those are equal, right? What x value is going to make those true. So they can help check their answers and see those solutions graphically as well as working through it algebraically.
Nolan, we do have a collection of questions
Okay.
whenever you are ready.
Yeah, let's do that now.
Okay. So the first, this one's going back a few minutes. Is there a list of keyboard shortcuts? So you were showing how you could do like Shift 6 to get an exponent. Is there a list somewhere of those?
Great question. I'm getting lost in all these tabs, but let me go to the graphing calculator. So the general graphing calculator, not the North Carolina version. When I go here and I click on this help menu, here it is, keyboard shortcuts. I also linked the user guide, which you can get here. I put that direct link into our agenda. So while we're here, I'll just throw that out there. But that has a lot of great visuals and basics. If you're just not sure where to get started, you could read through that. Some teachers like to print that out. But then the other one here, keyboard shortcuts, this pops up and you can look through the different shortcuts. So like I was talking about the Shift-6 to do the exponent here, the subscript, the shift underscore. You can just type less than or equal to. So if you do the less than and then equal to, it will put them together. If I do less than, and then I'm going to hit my equal sign. You can't see me doing this, but as I do it, it just puts them together as one symbol. So yeah, so that's where you can find that.
Awesome. While we're here in the graphing calculator, we have a couple questions. The first is there a way to have a table populate with a rule? So for example, if you had like one column that had your X values, and could you have it populate the second column with some kind of like 3x plus 5?
Yes, so a couple ways. If you put in the equation 3x plus 5, we can hit this gear. This is where I deleted everything. I did it kind of quickly. And we're going to do the high school one tomorrow. It's going to be a deeper dive into the graphing. So if you want to come back for that, we'll get some more nuts and bolts. But as I hit that gear, so what I hit again, I'll do it again, that edit list, this gear, this table right here, I can convert to a table. And so now I have my x's, and then my output y here, you can see is 3x plus 5. So it's taking those x's and giving me the output. I can hit enter to extend it, and it will keep that pattern. I can also arrow down, and I could put in any number I want for x, and it will give me that y value. And you also notice it is plotting that point, those points as they go on the table. I can find that other one. There it is. Yep. There. So I think that is what they were asking for. You can also just start with the table and just change this to, I want 3, and then instead of x, I just need to type the 1 after it. Since now this was a table with just x, now we're using x1. If we put another table, it would be x2 and so on. So then we'd be able to do the same thing there.
Awesome. All right, we have 2 more questions. So we're again with the graphing calculator. Is there a way, if you create your own table, is there a way to have it connect the points with a line?
So yeah, I just did that kind of quickly, but you can also type the word table. That's a little one of those shortcuts. So right now it's not registering, but as soon as I finish it, that pops up. So let's put in 1, 2, and 3, 4. All right, let's do 3, 5, just to make it a little more interesting. If I click and hold on this, or I hit the gear first and then click on it, I can connect those like a segment. So that's one way. If we want a line that goes all the way through, we would have to run a regression. So we can do that as well. So let me just show that one more time. So we got our table, 1, 2, 3, 5, let's say. I can click and hold here, and I can connect those with a line. And then you have some options too. It could be dashed or dotted. We can toggle back and forth. If I want to do a regression, if we know it's linear, I'm going to type in y equals mx plus b, and then I'm going to change 2 things. I'm going to reference this table, which is x1 and y1, so I'm going to type a 1 after the y and a 1 after the x. I didn't do anything special to do the subscript, it just automatically did it for me. And then the last thing I'm going to do is I'm going to change this to a tilde, because it's not going to be, in this case, it will be an exact one, but if we're running regression, usually it's an approximate equation. So I can hit that symbol there, and it will pop up my line of best fit. And since this is a linear relationship, I can see my slope and my y-intercept right there, and it will graph it for me on the graph there.
All right, excellent. We have one more question, and then we'll let them accumulate again for a bit.
Okay.
Can you show how to get the table button again using the plus sign at the top?
Sure. Yep, so all you do is hit that plus. This is the general one, so there's a few other options that aren't on the testing version, but it's under that option there as table. So then it pops up. I can do another one. You'll notice now it's x1, y1, it's x2, y2, so we can reference those in different ways throughout different expressions.
All right, thank you, sir.
Great. All right, and we're running a little bit on time, but I wanted to show So for this question, this is not what I'm about to show you. This is not what I would teach students to do, right, on the test with it. But this is a way to, as we transition to kind of using it instructionally, thinking about how we can get students to understand different concepts better. So when we talk about dilations and different transformations, I'm going to create this triangle and play around with it in the graphing calculator. And so what I've built already, and I have linked in the agenda right here, if you go to the polygon tool, I have a table here. And so those points are in green over here. And if I don't have the polygon, if I turn those off, right? So the table is just those points. And then I use this polygon command and I referenced these points. So what the polygon command does is it connects those points and it shades the interior. So we see that triangle here. We could add another point, and we could extend that polygon and keep going. Okay, but I want that triangle. And then what I want to do is I'm going to have a second one. And right now it's the same. So as I turn it on here, instead of turning it off when I click to the side, it's right on top of it. But I'm going to turn it off and I'm going to put a negative sign here. And so as we're learning transformations, I might ask my students, well, what if I do this? What's going to happen to this triangle? And, this would be like a think pair share. Just think like, what do you think this is calculators doing here? And what do you think is going to pop up over here? So we start getting students to predict. And so we might start that discussion and just think about, okay, well, it's going to take the opposite sign of all the y coordinates. And then give them some time to think and make predictions. And I love doing think pair shares, and students will have the hand motions going like, well, I think this is going to go here and things like that. So, and then they're going to be invested as we get to the reveal. So we can reveal by turning it back on, and we can see what's happened to a new polygon. We can talk about why. Was that what we expected? Why or why not? And we can have some really rich conversations with this nice, beautiful visual of a reflection over the x-axis and what that means numerically for each coordinates. So you've got that graphical representation, you've got that numerical representation. You're talking about some general rules of, negating or taking the opposite of the y coordinates. And then we can turn it back off and we can say, okay, now you got familiar with that. What happens? What if I do this? Okay. Now maybe you get a few more students that are able to figure that out, right? Maybe the first time they were super confused, like, Mr. Doyle, what are you talking about? Okay, now I think those x coordinates are going to change. Well, what's that going to look like in the picture? Boom. Turn it back off. What if I multiply all the x and y coordinates by 2? What's going to happen? Right? Get them to predict. Get them to talk about it. Maybe sketch what they think is going to happen. Turn it on. Ooh, is that what we expected? Why or why not? Think about what's going on. What if that's 1/2? What's going to happen? How is that different than when it was 2? Okay, so there's that exploration piece and the idea that students can make those connections themselves. And then we can come in as a class and generalize and maybe put some things in our notes of, okay, this is what's going to happen. And again, this is not something I would have students build, right? They don't have to know how to use the Polygon tool, but I have that linked for you, right? So you can play around with that and explore maybe the nuts and bolts of that a little bit more. So along that same line as we talk about, okay, I went to the basics and I've got some visuals there. And again, more of that with the graphing calculator tomorrow if you're able to sign up for that webinar as well. But as we think about Desmos for instruction, we want students to do predicting like that. We want to invite their informal before formal so they can describe in their own words what visually they're going to see. Start to see patterns and identifying building structures really where I think the teacher comes in to help with that. And then the huge thing of connecting representations. That's a huge thing that we want students to be able to do, not just us to tell them about that. So before we get to that, I just wanted to do a couple other things along those lines. So one feature I said was not available in the testing version was defining a function. But if I want to teach function notation, I still might show them the calculator first. So progression I like to do is sometimes use the technology at first. Get students to tell me, okay, what is the technology doing? Make sense of what's going on. Then remove it. Let students do it by hand. but then bring it back at the end. Okay, can you check your answers with it? Like, are you doing it correctly? Are you getting the same thing? So if I go into the graphing calculator, and you can do this in the testing version or the full version, but if I'm teaching function notation, they've never seen it before. I might graph y equals x plus 4. And then I might say, you know what, this is how we're going to start to use or write this. And it means the same thing. And I can show them, like, they don't have to take my word for it. Look, Desmos is graphing the same exact line right on top of each other. So this f of x is still representing the output, the y values. And then I might just start typing without telling them anything else. Like, okay, here's f of 1, here's f of 2, f of 3, f of 4, and just pose the question, what do you notice? Right, so what are some things? So we start having discussions after they think, pair, share again. Oh, I notice these go up by 1. Oh, I notice these go up by 1. Maybe I direct them to noticing patterns this way. Oh, it's a difference of 4 each time. How is that? Maybe convenient. Oh, up here, it's just adding 4. Right, so eventually we kind of get through, kind of pushing them along, this idea that, oh, this is the input, this is the output. This is the input, this is the output. This is the input, this is the output. And it's so much more powerful if we can lead them there and allow them to make that connection instead of just coming into class and saying, here's what function notation is, here's what this means, now do it. Right? It's so much more powerful if they can make those connections themselves. And if we've been talking about inputs and outputs, let me just hit enter here. Well, how do we pair inputs and outputs, x's and y's? Well, we could plot a point. Ooh, look where that shows up, right on the line. Where do we think this one's going to show? Oh, right there. Right. So now we have the different representations side by side and students making those connections between them. Right. So input output. This graph is an infinite amount of points where the input and output are tied together through this rule, through this equation. So that's one way where we want to kind of shift our thinking of, yeah, that feature is not available to your students to use, but when you're introducing the topic, can we use it to help them understand it better? Can we use it to help them explore it and discover it a little bit more independently with just our guidance and our questioning along the way? Another way we can use it, and we could do this with the actual testing version too, is, so this comes up in my Algebra 2 class. It actually came up the other day. We had something within a larger problem, right? A squared times a cubed. Some students told me it was this. Some students told me it was this. So I might stop class, we might have this discussion, like who's right, like having a good debate, right? And so students have to justify why they think it's one or the other. Some good conversations, and hopefully one student says, well, a squared means this. And then we're going to multiply that by a cubed, which is 3 a's being multiplied together. So it must be a to the 5th, right? So great conversation to have. But we can take it one step further and we can say, okay, let's make sure, let's confirm it. Let's define a value for a. So I can say a equals, give me a number, 7. And now we can talk about equivalence, right? The reason we can write this like this or this is that they're all equivalent, and they're equivalent no matter what, right? The number is that we put here. We could put in pi, right? Students can keep naming numbers and we can show which expressions are equivalent, which ones aren't. So it reinforces some really big concepts of equivalence as well as variables, right? This idea that a is just some number. We just don't know what it is. It could be -12. It could be -120, right? We don't know what it is, but it is a number, right? It can be any number. And so when we have equivalent expressions, what we're saying is no matter what a is, that expression is going to have that same value. So we can reinforce some of those rules that they're memorizing with some of those major concepts of variable, of equivalence. If you do that in the graphing calculator, kind of wrap up with this, it's even a little bit more powerful because we can quickly use a slider. I did that kind of quick, so let me go back here. So when I put in a, it prompts me on the graphing calculator, like that's not x, it's not going to graph this. It's going to add a slider here. So I'm not going to do it yet. I'm going to put in a to the 5th. I'm going to put in a to the 6th. And then I'm going to do this so we can see it a little bit better. Now I'm going to add that slider. And now I can quickly change that value for A, and we can quickly see all the different values of the expression as I change the value of A. It's just a powerful visual of those concepts that sometimes we take for granted when we just see math as just this manipulation of symbols and we lose the meaning behind it. And then the last thing I'll just show with sliders is we could translate it to an equation. So we could put in y equals mx plus b, and we can quickly see what's happening and let students describe it in their own words. Eventually get to the idea of direction and steepness are changing here. This, we could talk about it shifting and moving. You can quickly click and maybe make a connection to that y-intercept. So the sliders are really powerful tools instructionally within the calculator too. All right, so I'm going to kind of wrap up here and check in on questions. As I do that, I'm going to just make sure I touch again on the agenda here. So the links that I talked about to the different calculators, the main ones being the testing versions. This is the PDF of all the information you need for North Carolina testing. Some support for either calculator if you're not sure where to go next to explore the calculators, those are great. And then some general resources. The YouTube page is super helpful. There's full webinars. There's also quick video links of just how to do different things and more professional development that's available there. So also don't be afraid to email the support team. They're super responsive no matter what the question is. It doesn't have to be a large question. It can be a small question. You have my email as well. I'd be happy to help out. And then also if you could fill out this survey as we wrap up here, that'd be super helpful, as I mentioned, not only for us to tweak how these sessions go in the future, but what new sessions are you going to need moving forward? What supports? What do you want to see on the help page? That stuff about like the iPad, right? Those are things that we want to know because we want to make sure that this is working for you and your students in the classroom as best as possible. So thank you all. Like I said, I'll stick around if there's any questions. If you don't mind filling out that survey too while we do questions.
So we have two questions, one for you, one for me.
Okay.
So we have a lot of interest in the graphing calculator and using it as a teaching tool. So for teachers who are more familiar with the scientific calculator, can you show again on the Desmos website how they can get to some support for the graphing calculators and the different functions that are available on the graphing calculator?
Sure. So from the agenda, this link here, support for the graphing calculator, that takes you to the general help.desmos.com, but specifically to the graphing calculator. So there's a video there, getting started, FAQs, and then you can look in more detail at functions or those keyboard shortcuts we talked about. So there's different categories underneath here if you wanted to go back, progression, look more sliders that we talked about. So this would be your go-to for that, as well as the webinar we are doing tomorrow. Just a little plug for that, right? Which will be, I'll go into more detail because I won't spend any time on the scientific calculator piece of it.
Awesome. And then a couple questions for me. Folks are noticing that we are recording and they are wanting to get a copy to go back and review later. Yes, this afternoon, late today, early tomorrow, you will receive an email for anyone who registered, whether they joined us live or not. And the email will have a link to the recording, which you can share with your colleagues. And then that will also have all of the links. So it will have the links to the agenda, the links to the North Carolina Scientific Calculator, and the links to the slide deck. The only tricky part about that is the email comes from a larger listserv, so it'll come from NC Public Schools. So you may have to check in your spam folder for it. It doesn't come from WebEx and it doesn't come from me. So you will have to check for NC Public Schools. So please look for that. And then the next question is a question about certificates and CEUs. We are not able to offer certificates or CEUs. And with that, I think we have we have cleared out our questions. I want to say thank you again for wonderful content, for really sharing some innovative ways to use the calculators as tools to teach and for exploratory learning. And if anyone is interested in joining us tomorrow, if you will let me know, I will be happy to send you the link to register. We do have seats available for tomorrow if you would like to dive deeper into the graphing calculator, which we embed for grade 8 and our high school maths. And with that, I will sign us off for tonight. And thank you again to Nolan.
Thank you all.